Tonight's episode 3 of building catenary. Last time I talked about the height off the rail, and it's kind of a misnomer. Mine's actually 22 feet off the top of rail. It's not 25 feet, so my bad. If you started hanging wire and your wire's too high, you just have to lower your poles a little bit. But anyway, the poles, the single poles, like are on this bridge right here, they're 30 feet. Now if they're in the, for example, if they're in the roadbed, they're actually a little longer now, so that'd be 30 scale feet. Add about another 10 feet to stick it down into the bench work. And the spacing on the poles themselves, for on this one right here, I'm gonna zoom in a little bit. I know it's hard to see some of this stuff. Let me find a better pole in a different location. But on the bridge, from the top of the pole to the hanger, that's the wires coming down at an angle. That's 2 feet, or that's the support of my bed. I'm going to use that word a lot tonight, sorry. The hanger wire, the one that goes out and holds the catenary, that's 4 feet from the top of the pole. Actually 6 feet from the top of the pole. So up to where the support wire comes down, that's 2 feet from the top of the pole. And that curves down underneath poles. On the bridges, what I've done to attach them to the bridge. Now remember, these are all welding rod. These are not plastic. These are not wood. It's wood and plastic are not strong enough to support this. I need my prop. Inside here, I'm going to find what I'm looking for. Here we go. No. Here. Inside here, at the base of this pole, right here, helps if I put the camera on. This pole is notched down here on both sides. An 025 piano wire is soldered. There's 4 pieces that are soldered to this pole, and they're about 3 inches long. And what I do is I then line this pole up where it needs on the bridge, drill the girder 1 hole at a time, then line this up with a level so it's vertical and plumb. Finish all 4 holes, then slide this whole thing in to the bridge itself, and that alone will hold it up. I then take pieces of the bridge material to go over top of it to give you the lattice work. Now that isn't true to the Milwaukee prototype, but it functions, and the Milwaukee ones are a little bit different design than this. And again, you're trying to make working catenary, and sometimes you just can't do what the prototype does because theirs is all made out of structural steel, forged and fabricated somewhere else and bolted to the bridge, and to scale that doesn't work too well. One of the other things I wanted to talk about was pole placement. And in this diagram here, every place you have a dot, that's a pole, 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 so on and so forth. Where you come over here, these are what your portals would be. Either on the bridges that are timber structures, or they're just 2 poles set on either side of across from each other with just a span wire across the middle. And then as you notice, your poles, your single poles, go to the outside of the curves. They're always on the outside of the curve. There are a few exceptions. The reason the portals are here is this is where your transition is. If I'm coming from here going this direction on the outside of the track, once I get to this point, I'm transitioning to the inside of the track. This is for stabilization because the catenary is going to want to hog either this way or this way depending on the tension on it. So when you attach this one and this one, you may or may not have to have pull-offs on there to keep it straight. This will keep that from happening. Also, as you're working, you want to work when you're laying this out in curves and work. You just want to work from one direction at a time. And you always want to keep your tension going in the same way. we'll walk over to another section here in a minute, I'll show you. So as you're laying your wire, the compressor is going to start, you're going to basically be putting tension on it as you go, and you're going to have tension going this way. You're going to have pull-offs. Your down guys on your poles are going to be pulling the pole away from the center line of the track while you're pulling tension on it this way. So let's walk over and I'll show you a little bit more of what I'm talking about. Up here are the portals I'm talking about. These are made out of brass. I think it's 1/8" brass from K&S. But what I did was basically, it's just square tubing. Same principle to hanging on the bridge down here. These are all wires soldered onto it down here. This is cut and notched on both sides to just receive this piece that fits across the top. So this piece drops in, that's soldered, and then these wires that come up on the Milwaukee actually should be, these should be wood beams, support beams, but these are made out of wire. It's just cut and soldered, drilled and soldered. They can make it rigid. But as this pole right here is a good example of, you have a pull off in this direction right here. If I can zoom in enough where you can actually see it. But that's keeping tension coming across the bridge. The one back here that goes to the stub pole in the back, the only reason that's there because there's a road here, access road. That's on tension pulling toward the outside of the curve. And this keeps everything in alignment going around in itself. Over here, you'll see that's on the outside. And then we have a portal. You normally need two, not always. And then again, there's your hangers. Now, I'm trying to find one. Well, down here, I guess, is a better way of looking at it. Bear with me. That's a timber portal right there. As you can see, it's guide to both sides. There's a guy wire here. And there's a guy wire over here. And the reason for that, you can't really see it in the video, but if I put this, you'll see there's a curve going into the tunnel. Now, on this pole here, again, like I said, this is from top to bottom. I'm just having a hell of a time. The pole itself, the wire's 22 foot off rail. The pole itself is 32 feet. What is it? It's 30 feet to the top of the pole. In the yards, I have them at 32 feet, and the main line are 30 feet. But you can see here, this is your pull off here. And a lot of these, in Noel Holley's book, he has a nice drawing of what they did on the poles, and you can pretty much follow that. It's not that hard. You just make a scale drawing. This is 1/8 inch, so if you use an 1/8 inch pole, it's not too hard to figure out the spacing on these. This is 0.25 piano wire. This is 0.15 piano wire at the top, and this is 0.10 for the pull-offs. And those you need those 2 points of contact to keep the wire straight. And otherwise it's going to want to, if you just use the 1 point at the top, it's going to want to swing one way or the other. Especially when the pantographs are riding, I'll just push it over. On this one here, much like the real prototype, over the St. Joe River, the guy wires are on the other side of the river. But all these guy wires basically keep the catenary in place as it goes around. One of the last things, well, I got a couple things I want to tell you about, and then we'll talk about the last thing. On tunnels up here, I I said, you have to decrease your clearance because of the tunnel portal itself. That whatever height tunnel portal you're using, I was using the, I can't think of the name of them off the top of my head. They have those plaster concrete ones. But inside the tunnels themselves, that's all basically just straight welding rod. And the piece of the catenary that I tell you to cut off, in the sections of your tunnel, don't do that because that slides right over the welding rod. You take a welding rod, bend it into a 90-degree angle, and then slide that over top of it. You can solder right to that and you're good to go. You need to, when you're doing the tunnels, you need to, what's the word I'm looking for? You need to basically build everything inside the tunnel itself before you do the hard shell scenery. On these ones here, these all have liners in them because these were all built off the railroad out of foam. I glued a bunch of foam together, then used a hole saw to drill through it. Since these are curved, that basically just had to play a little bit of math to figure that one out. And then using a wood rasp and foam work really good for smoothing stuff. You can cut a lot of foam quick with a wood rasp. But that gave me a diameter, and then I punched wire down through the foam itself to hang the catenary inside the tunnel before I did the scenery. So some of this stuff you have to pre-plan. On this tunnel here, this one's all lined with concrete, which is actually just foam core. But again, that was all installed, the wire was installed, and then the foam core, the whole thing was built around it before any of the scenery was put in place. And it's a lot of testing you need to do as well. On the Little Joes, my minimum radius I've been able to do for the Joes themselves is 32 inches was the minimum. Anything below that, they weren't happy. So that kind of set the benchmark for that. Now what you'll find when you're doing hanging wire, you need a couple electrics, whatever you're going to run. The Joes have a different swing point on the pans versus the box cabs. On all my box cabs, I had to change the pantographs to a wider shoe because they would run right off the wire because they have a different pivot point and the pans don't track. We're modeling a railroad that the tightest radius curve they had was 10 degrees, which is 79-inch radius curve in HO scale, and none of us have that kind of room to play with. So, I mean, if you did, you didn't have to, a lot of this stuff you wouldn't have to worry about. Oh, I think that's about everything I can think of on catenary. If I think of anything else in the future, I'll gladly put something else together, but I guess that's all for now.